All right, hello guys. It's your favorite math teacher. Obviously I'm not here today, but lucky you, you still get to take notes. So, we are going to be in section 7.5. This is the last section in chapter 7 that we are going to cover. So, if you open up to your notes, let's go ahead and split our page up so we can get that taken care of. We're going to do 3 examples in the first section, 3 examples in the second section, 3 examples in the third section, and then just 2 in the last. Okay, so if we jump up here to the top, what we're going to talk about today is rational exponents and radicals. So rational exponents, what that word means, rational number is just going to refer to fractions. And we kind of did a little bit of fractional exponents, but I kind of avoided most of those problems altogether. But this isn't too bad. So what we're looking at is we're looking at powers that has an exponent that's a fraction. Okay, so what we're interested in today is we're wanting to go back and forth between powers to a radical, and this is really, really easy to do. So if we talk about a radical, so a radical is another word for a square root, except something you probably haven't dealt with before now, a square root. That's not the only kind of radical that there is. So a square root, as a reminder, if I have the square root of 4, what we're asking ourselves is what times itself gives me 4. Okay, well that would be 2 times 2, so the square root of 4 is 2. So whenever we talk about the different parts of a square root, what we don't really talk about is that there's an invisible 2 there in front of at the top left-hand corner of that radical. That number is called the index. Now, if you don't see a number, like I said, it's automatically a 2. So if I have the square root of 16, there's an invisible 2 there. We don't usually write it, but today we are going to need to make sure that we understand that that's there. And then once again, the square root of 16, we'd be saying what number times itself gives me 4. Now the reason why we say what number times itself, okay, notice there's 2 4s, it's because that index is 2. They go hand in hand. So for example, if I was looking for the cubed root of 8, I would be looking for what number multiplied by itself 3 times will give me 8. Okay, well that would be 2 times 2 times 2. So the cubed root of 8 is 2. Okay, so we've talked about kind of the different parts a little bit. Let me get rid of some of this. Okay, so we have, that's the index, that invisible number in front of the square root, okay? The exponent, okay, we obviously know what an exponent is, okay? That's the little number in a power. So if we want to go back and forth between a radical and an exponent, this is the phrase that you need to remember. Exponent over index. So what that refers to is if I want to go from a radical to a power, the base stays the same. So if the base is an x inside the radical, the base is an x outside the radical. And then, like I said, the exponent's going to be a fraction. So to know what that fraction is, we are going to take the exponent, in this case, which is e, over the index, which is I in this case. And remember, if you don't see a number written there, it's a 2. Okay, this kind of makes more sense once we actually plug numbers in there. So let's go down here to this first one. We're going to want to know what the value of each expression is. So our first example, we'll keep it pretty simple. If I want to know the square root of 49. Okay, now, we know what the square root of 49 is, but let's concentrate on what exactly it's asking me. Now remember, I don't see a number there in front of these square roots. There's actually a 2 there, but it's kind of like the 1 in front of x. If I have a 1x, we don't normally write it. Or if I have an exponent and I don't see it, it's a 1. It's kind of the same thing, except it's going to be a 2. And what that means is I need one number multiplied by itself 2 times to give me 49. And since that's number 7, that's why the square root of 49 is 7. Okay, you can also say, well, 7 squared gives me 49. Those are opposites. They go hand in hand. So if I want to know what the cubed root of 216 is, what I'm asking myself here is what number multiplied by itself 3 times would give me 216. Now for these ones, you may just have to do a little bit of guessing and checking. If you do 2 cubed, it's going to be 8. 3 cubed is 27. 4 cubed, 5 cubed. If you plug in 6 cubed, okay, or 6 times 6 times 6, that's going to end up giving you 216. So since 6 multiplied by itself 3 times, or 6 cubed gives me 216, the cubed root of 216 is 6. Okay, and you can raise this index as high as you need it to go. So if I'm looking for the 4th root of 625, since my index is 4, I need a number multiplied by itself 4 times. That gives me 625. And once again, you may just have to do a little guessing and checking. Or if you don't want to take a number times a number times a number times a number 4 times, we're looking for, okay, what number to the 4th power equals 625. That's what we're really looking for, which is going to be 5 times 5 times 5 times 5. So the 4th root of 625 is 5. Okay, so that part's not too bad, but we have to know that before we go on to this part right here. So this part says we want to write each expression in radical form. So we're going to need to see that squared root, or if it's not a square root, a cube root, a 4th root, and so on. So we want to make sure we also simplify if we can using these rules that we had above. So let's say we have in parentheses 8x and then in parentheses to the 1/3 power. Okay, so what we want to do is we still want to use those rules of exponents that we have been learning all last week and this week. So this is where, I know you can't see me, but I'm doing the air quotes here, okay? This is where we want to distribute the exponent. So this is going to be 8 to the 1/3 and x to the 1/3. Now I can't really do a whole lot with that. It's kind of like a negative exponent. A rational exponent is kind of hard to deal with. So what we want to do is we want to write this in radical form. So remember, in radical form, we're going to take the base stays the same, okay? The 8 stays the same. The numerator is your exponent. So this is 8 to the 1st. The 3 is your index. If I do the same thing with the x, the base stays the same, and we're going to take exponent over index, which is the same. It's going to be a 3. Okay? And then the last thing we want to do is we want to see if there's anything I can simplify. So what we're looking for is this number right here. We're looking to see if I can simplify the cubed root of 3. So we're asking ourselves, is there a number multiplied by itself 3 times that gives me 3? Okay, well it is. It's going to be 2. So that 2 is just 2. It's no longer under the radical. So we're going to have 2 cubed roots of x. I could not do anything with the x, so it's going to stay where it was at. Okay, let's try another one of these. Okay, what if I have 25x to the 2/5? Okay, so we want to probably first write it in radical form, but you have to be really careful here. Kind of like whenever we were talking about the negative exponents, you have to be really careful about what actually has a rational exponent. And if you look really closely at this, the only thing that has a rational exponent is the x. That 25 does not have a rational exponent. So that 25, we're going to leave it outside the radical. We're not going to do anything with that 25. That x is going to have to come under the radical sign. And then to figure out what is going to go here for your exponent and here for your index, we're going to take exponent over index. So this is going to be x squared, and then the index is going to be a 5. So I have 25 and 25 fifth roots of x squared. And for this one, that's all you would be able to do. So that's how you would leave your answer. Okay, if I try 16 x to the 4th to the 1/4. Okay, kind of like the first one. Once again, you can't really see me. You can't see me. I'm doing the air quotes here. We're going to distribute that 1/4 because they're actually in the parentheses. So we're going to do 16 to the 1/4. When I do x to the 4th to the 1/4, we're going to apply another exponent rule. This is a power to a power. So the 4 and the 1/4, I'm going to multiply those. Well, when you take 4 to the 1/4, you get 1. So this is 16 to the 1/4, x to the 1st, or just x. So the last thing we want to do is I want to take this rational exponent and write it as a radical. Kind of like in the last one, I want to make sure I only put things in a radical that actually has a rational exponent. That x does not have a rational exponent, so that x is going to stay outside the radical. The 16 does have a rational exponent, so the 16 is going to have to go under the radical. Okay, the 1, that's your exponent, over index is your 4. And then if we look to simplify 16, the 4th root of 16, we're looking for what number multiplied by itself 4 times gives me 16. And that's going to be 2. So that 2 is going to come outside with the x, and I actually have nothing left under the radical, so that's how we leave our answer. Okay, down here we're going to do almost the same thing, just going the opposite direction. So this time we're going to write each expression in exponential form. So let's start with, not that either, the square root of x to the 5th. Okay, since it's already in rational form, if there's any simplifying we can do, we want to go ahead and do that. Now, since there's no number, there's not really any simplifying I can do. So we're ready to take this and write it into a rational exponent. So the base, that x, stays the same. It's still going to be an x. Okay, and I know I'm going to have it as a fraction, and remember this is exponent over index. So when I'm talking about the exponent, that's the 5 right here. Now the index, that's the number that we write right there. And if you remember, if I don't see one, it's a 2. So this is going to be x to the 5/2. If that were a fraction that you could reduce, you would want to reduce it. So if that exponent instead was a 6, you would want to go ahead and reduce that as a fraction as much as you could. Okay, let's try the square root of 49x. So before you change this into exponential form, if we can reduce anything, we want to. Okay, well, I've got a 49 under the radical sign. Remember, this is just a square root since I don't see another number. So this is where you're looking for a number multiplied by itself 2 times. That gives me 49, which is going to be 7. So the 7's going to come out from underneath the radical sign because the square root of 49 is just 7. But the x is going to stay on the inside. So whenever I'm writing my number in exponential form, that 7, nothing's going to happen with the 7 because it doesn't have any kind of weird exponent. It's just a 7. But this x, when I bring it out from under the radical sign to write it into exponential form, the base stays the same. The x stays the same. For the fraction, I need exponent over index. Now I actually don't see either number. So on the x for the exponent, remember, if we don't see a number for the exponent, it's a 1. For the index, if you don't see a number, it's a 2. It defaults to a square root. So this would be 7x to the 1/2. All right, one more. Let's do the square root of in parentheses 3x in parentheses to the fourth. Okay, for this one, there's a couple ways you could go about this one. What I might actually do on this one, instead of, once again, air quotes, distributing that 4, what I might do is I might actually take this and go ahead and write it into exponential form. Just because this is kind of condensed in a simple answer already, and I know it's a lot, but the base for this exponent is 3x. So if I take that base and instead of writing it in radical form, if I want to write it in exponential form, we would put the exponent, which is a 4, over the index, which since I don't see a number is going to be a 2. And we would want to still keep that 3x in parentheses. Okay? Now if you notice, the reason why I did this is you see that 4 over 2, that's a fraction that we'd want to simplify. 4 over 2 is 2. And now I have 3x, the whole thing squared. Now I can, air quotes, distribute the squared. We'd have 9x squared. If you wanted to distribute, air quotes once again, the 4 in the beginning, you absolutely could. But in that case, it might be easier to go about it that way. All right, and last two problems here. Let's say for the next one, we want to simplify the expression using the properties of exponents, and then we want to finally write the expression in radical form. So radical form is where you see the square root or cubed root or so on. So let's say I have x to the 1/4 times x to the 3/4. Okay, if we think about what we're doing here, take this all the way back to the middle of last week. All right, we are multiplying powers with the same base. Okay, and I know the exponents are fractions, but it doesn't change the rules. Anytime you're multiplying powers with the same base, you're going to add your exponents. So this is going to be x to the, when you take 1/4 plus 3/4, I'm adding fractions. They already have a common denominator, so if I add the numerators, I get 4. Keep the denominators, I get 4. And this is another case where if you have an exponent that you can simplify, you want to go ahead and simplify. So 4 over 4 gives me x to the first, or we'd normally just write that as an x. Okay, what about xy to the 1/5 times x to the 2/5? Okay, so first thing, normally what I tell you to do, except in special cases, air quotes, distribute the exponent. So x to the 1/5, y to the 1/5. When I distribute, air quotes, the exponent, there's actually only one thing to distribute it to in that second set of parentheses. Okay, now whenever we look to simplify this, if you look at the x to the 1/5 and the x to the 2/5, that would be multiplying powers with the same base. So if we do the same thing we did on that one just there to the left, if I add those exponents, I'd have x to the 1/5 plus 2/5 is 3/5. And then if I take y to the 1/5, we'd leave it like that. Okay, so now what I want to do is I want to write this in radical form. Okay, so in radical form, the first thing that I notice is I see they both have a 5 in the denominator. Okay, which means, remember it's exponent over index, which means both of these have an index of 5. So what that tells me is I can write both of these under the same radical sign. If they had different indexes, they would have to be in separate radicals. But since they have the same index, we can squeeze them under the same one. So my x and y are both going to come under the 5th root. The exponents, remember that's your numerator, exponent over index. So the 5th root of x cubed, y to the first, or just y.